Today we're going to be graphing systems of inequalities that have 3 or more inequalities in them. So we're going to do this the exact same way that we've always done, where we're going to graph each of the inequalities. After we're done, we're going to state one solution to the system. Remember, that means that it needs to be something that's true for all of them. We're going to then kind of extend our thinking. So we're going to name the shape that's created from the solution area. We're going to state the vertices of the resulting shape and find the area of the shape. So this is going to build in some of our previous knowledge, as well as what we've been, like previous knowledge from middle school, and then also stuff that we've done earlier with Algebra 1. So here we go. If we have y is greater than or equal to x minus 2, y is greater than or equal to negative 1/2 x minus 1, and y is less than or equal to 2, we're going to graph those. So technically it doesn't matter which one you do first, but let's go with this first one. So I'm going to use red for that. If we have y is greater than or equal to x minus 2, that means that our m is 1 over 1, and our b is a negative 2. So we're going to begin with b at negative 2, and then follow our slope. And we're going to make a few points here. The more points you make, the more accurate your graph is. So I'll make a few more. Alright, and then we have to decide how we're going to connect these dots. So since it's got a greater than or equal to, we're going to connect these with a solid line. And we're going to go all the way through our graph. And then it says y is greater than or equal to, so with that line we're going to shade above. And for this, because we're going to have a lot going on with this, we're going to just shade a very little bit so that we can show that we're going to be above the line with that. Okay? So then let's move on to the next one. We have y is greater than or equal to negative 1/2 x minus 1. So here our m is going to be negative 1/2, and our b, our y-intercept, is going to be negative 1. So we're going to start at negative 1, and then we're going to go down 1, right 2, down 1, right 2. So down 1, right 2. And this line should look like it's going downhill. So we're going to go a few in the other direction here. Alright, so once we're here, we're going to connect these dots as well with a solid line. And since it says y is greater than or equal to, we're going to shade above that line. So again, to make this easy, we're going to work on shading above the line there. Okay? And then our last and final one is y is less than or equal to 2. And so when we have that, when we have just a number, we're going to go to that number. Since it's y is less than or equal to 2, we're going on the y-axis at 2. And that means that it's going to be a solid line going straight across, okay? Because we want every point on this line that we're creating or graphing to have a y value of 2. Now, since it's y is less than or equal to 2, we're going to be shading down from that. Okay, so then where is the solution area to this? And the solution area is going to be where all of those colors cross with each other. Okay? So that means that we're going to be in this space in the middle. Now, it does say first to state one solution. So one solution is going to be a point that is in the middle of all of these shadings. So if we look, the easiest point to always find is 0, 0. That's in here, that's in the middle. So our one solution could be 0, 0. Obviously, there are lots of other solutions, so you could go 1, 1, 2, 1, things like that. You could also choose something that's on a line, but I would caution you with that. Just be careful, okay? So one solution. The next thing it says is to name the shape. Okay, we're going to name the shape. So if we're looking at these here, where this all is, it's going to be a triangle. Now it says state the vertices. Vertices are where we're going to say the corners of these would be. So here, here, and here. Okay, so this one's a nice easy point of negative 6, 2. So I'm going to put letter C down here. We have negative 6, 2 is one vertice, or one vertex. Here we have 4, 2 is another vertex. And then the third one is not actually a nice, easy point, but for that, you can type them into Desmos and see where they cross. So those are going to cross at 2/3, -1 and 1/3. And for that, that's something that you could even write the decimals for those. But this is 0.6 repeating, -1.3 repeating, so you should know what those are as fractions. The last thing is to find the area of the shape. Okay, so since this is a triangle, we need to remember the area of a triangle formula, which is going to be A equals 1/2 base times height, or base times height divided by 2. So we're going to fill in our information. Now, the base of this triangle is going to be this here. So if we count that distance, we get 10. So the base of this is 10. And the height is going to be this vertical distance. And for the sake of ease, we're just going to say that that's 3. I know it's not exactly 3, but for this, it's okay if we do that. So 1/2 times 10 times 3, half of 30 is 15. And then we do need a unit with this, so we're just going to say square units because it's area. Okay? So this is what we're doing with these questions. We're graphing the system. We are naming one solution, naming the shape, stating the vertices. Desmos can help with that, and then finding the area using our area formula from the past. Okay? So let's look at this one here. So same directions. What we're going to do now is have 4. Okay? So here we go. We have x is less than or equal to 3. So when it's x in a number, we're going to go to the x-axis on that number, and this is going to be a vertical line here. And since it's x is less than or equal to, if we're here at 3 where x value is less than that, that's going to be over here to the left. So we're just going to shade a little bit with this because there's going to be lots of shading on this question. All right, next one. We have y is less than or equal to 2. So that means since it's just y in a number, we're going up to the y-axis at 2. And we're going to have a horizontal line. Again, it's solid. So now we're going to shade below that because it says y is less than or equal to 2. Next one says y is greater than or equal to -2. So we're going to -2 on the y-axis. And we're going to connect that. We're going to make a solid line all the way across. So a horizontal solid line at -2. And it says y is greater than or equal to, so we're going to shade above. And last but not least, we have x is greater than or equal to 0. So we're going to where x is 0, which is right here at the origin. And then it is going to be a vertical line. And x is greater than or equal to, so we're going to shade over here to the right. So our solution area is going to happen right here where all of those shadings cross. Okay, so naming one solution, finding a point somewhere in that area. So like this is a nice easy point. So 2, -1 is a solution to this. You could put 1, 1, 1, -1. Could we choose, 3, 0? Yeah, that's a solid line, so that's okay. You could technically count any of these corners since they're all solid lines. That's good too. All right, so the shape here is going to be a rectangle. And then we're going to state the vertices, so we'll do that down here. So the vertices would be 0, 2, 3, 2, 0, -2, and 3, -2. And you wouldn't have to list them in that order as long as you have all 4 of them. You're good to go. All right, find the area of the shape. So the area, this is a rectangle, so the area is just base times height or length times width. So here our base is going to be 3. And our height is going to be 4. When you multiply those, we get 12. And again, we're writing units squared. Okay. So let's look at these things. So what you're doing here is just graphing them and then following those instructions of stating one solution, just like we've practiced in the past, And then we're going to extend our thinking. So we're naming the shape, stating the vertices, and finding the area. It should either be a rectangle or a triangle for our questions today. So just make sure you're looking for those things, and Desmos can help as well. That's it.